When we discussed PIM sparse mode and PIM dense mode, we had a single multicast sender. But there might be times where we have multiple devices in our network that might be sending up multicast traffic. And one option is certainly we could create a separate distribution tree for every single source. But if we have lots of sources, that's not going to scale very well. What we might consider instead is bidirectional PIM. And with bidirectional PIM, we're going to have a single shared tree, as opposed to every single source having its own distribution tree. And we're still going to have an RP, a rendezvous point, and that RP, its responsibility is to construct this shared distribution tree. But here's what's not obvious. Even though the RP is constructing the distribution tree, it's not necessarily part of the tree. Notice the solid green lines on screen, that represents the tree. And although the RP is communicating out to the different routers and coordinating the formation of this tree, it's not part of it. Traffic is not flowing through the RP, and we call it bidirectional PIM because we've got bidirectional flow on all links. And we might even have a device on this tree or multiple devices that are receivers part of the time and senders part of the time. And in a large topology, instead of having all of those separate distribution trees, one for every potential source, we don't have any source-specific trees. We just have this one big shared tree. This might result in some suboptimal pathing, but oftentimes if we have lots of routers and lots of potential senders, it's worth it for the scalability we achieve by having a shared tree. Here are a couple of use cases where we might use bidirectional PIM. Let's say that we have some sort of a conferencing application. Maybe we have devices that are sending video and audio and they're sharing a whiteboard. So at any one time, I might simultaneously be transmitting traffic as I'm drawing on a whiteboard and receiving traffic as somebody else in the conference is talking. And we can do that with the same shared tree using bidirectional PIM. As another example, maybe we have some sort of emergency communications network, and we've got all these different locations that are sending updates to one another about a situation. Well, same thing as with a conferencing application. We might have a device at one of our locations that is simultaneously transmitting updates while also receiving updates. We might have multiple senders and multiple receivers. And the efficiency that bidirectional PIM gives us is that they are all using the same shared tree.